Welcome to Programming with Python session 5. Let us start this session by discussing logical operators supported in Python. There are three logical operators that Python supports. One of them is AND, OR, and then NOT. Okay. All these logical operators are used to combine the conditional statements. So if we have more than one condition to be evaluated, they have to be stitched together with one of these logical operators. Okay. So and or, these are binary operators, meaning at least two conditions are required when you have to use and or. Not is again unary operator. Not is used only with a single condition. Let us look at some examples. Every logical operation comes with something called truth table. So here, in general, 0 is represented as false while 1 is represented as true. Okay. And 0 and 1, 0 means false as I said. 0 represents false. False and false is false. Okay. 0 and 1 is also false. Okay. 1 and 0 is false. 1 and 1 is true. This indicates that if and only if both the conditions are true, the result will be true. Okay. If and only if both the conditions are true, then only the end result would be true when you are using AND logical operator. And here is just an example of two conditions, but AND can be used, or AND and OR, both of these can be used with any number of conditions. Okay. The thumb rule here is if and only if all the conditions are true, the end result would be true. Okay. Let us look at some examples. In programming, we don't use 0 and 1 or 1 or 0 in general, but we will be using some conditions in the place of zeros and ones because those are the conditions that have to be evaluated against. Let us look at the first example. 5 greater than 8. There are two conditions here. 5 greater than 8 is one condition, 9 less than 4 is a second condition in the same expression, correct? So this is where logical operator comes into picture. How do you really evaluate more than one condition, more than one conditional statement? Okay, 5 greater than 8 is one condition, while 9 less than 4 is a second condition. First, you evaluate the first part of the condition, which is 5 greater than 8. 5 greater than 8, the condition is false. So this can be represented as 0. And second condition, 9 less than 4 is also false. That means second condition also can be represented with a 0 or false. Finally, this condition becomes false and false. False and false is false. Okay. Similarly, let us look at the second condition. 5 greater than 0, which is false. Keep it in mind that when you are using a logical AND operator, if at least one condition has been evaluated to false, it doesn't keep evaluating the rest of the condition. Why? Because one false condition is enough to turn the end result to false when you are using AND logical operator. Hence, it just evaluates 5 greater than 8, which is false. Then it immediately returns the result as false. Looking at the third example, yes, conditional operators or relational operators in the first place can be used on characters. Hence, C less than F the capital C, the letter alphabet C comes before alphabet F is what this condition states, which is true. Okay, true and 9 less than 1 is false. True and false is false. Hence, the third condition will result into false. And the last example here, cat is less than cap. Okay? Cat is less than cap. So the first character in cat will be evaluated against the first character in the cap. C and C, they are same. So we cannot take any decision here. So it moves to the next character, which is small case a in the cat and small case a again in cap. Both the characters are same. We cannot take any decision over there. Then it comes and checks the character T from cat compared with character P from cap. T less than P, which is true. So true and interestingly is the second part of the condition is just one, which means it is true already. So true and true is true, hence the end result would be true. This is how the logical AND works in Python. So quickly, let us use IDLE and understand this better. I have opened a new session in IDLE, right? So first of all, let us evaluate 0 and 0. See, the result is 0. 0 and 1. It is also 0. 1 and 0. 0. 1 and 1, which is 1. So this is the summary of the truth table. Instead of that, we can also use false and false. False and false is false. False and true is again false. True and false is false. True and true is true. Hence, when you are using a logical AND operator, the end result would be true if and only if all the conditions that take part of that entire condition are true. All right. Now let us take the examples of 5 greater than 10 and before going ahead with logical orders, 5 greater than 10, 5 greater than 10, first of all, is it true or false? 5 greater than 10 is false. So, if I have to club multiple conditions together to evaluate as a single condition, then logical operators can be used. One of those logical operators is AND. 5 greater than 10 and 1 greater than 3. What would be the result of this condition? 5 greater than 10 is false. So the first part of the condition itself is false. So it doesn't even need to evaluate the second part. So the result would be false. Similarly, 5 greater than 10 and 3 greater than 1. Second part of the condition is true. However, the end result would be false because at least one false condition is enough to turn the result into false when you are using logical AND operator. All right. Now, 10 greater than 5, which is true, and I want to make the second condition false. This evaluates to true and false. True and false is false. So the result is false. 10 greater than 5, which is true, and 3 greater than 1, which is also true. True and true. is true, so the result is true. This is how we can use logical AND operator. Okay, so simple example: true and true and true. In this case, I have used AND two times, right? True and true. The first part of the true and true will be evaluating to something boolean, some boolean result. That boolean result and true is what I'm asking for. So this is how there is no limit. You can go ahead and add as many number of and logical operators within your expression or condition. So ultimately the result would be true in this case because all the conditions that you're checking are true. Same thing, true and true and false. And true, for example, this evaluates to false. As I said, just one false condition is enough to turn off the result to false. This is how you should understand the logical AND operator. Keep in mind that any value which is non-zero is treated as true. So 5 and 3. Can you guess the answer? There is no condition here in its own form. However, 5, which is a non-zero value, is treated as true. 3, again a non-zero value, which is treated as true. True and true is true. So here you can probably use, this is a different story. I'll talk about this later, why you got 3. But keep in mind that this is going to be 3 is again true, right? So 3 can be treated as true, right? This is how AND operator can be understood. Okay, 0 and 0, which is again 0 because it is false and false, which is false. Okay, 0 and 1. Sorry, 0 and 1. False and true, which is false. Okay, so the result is 0. This is how you need to understand AND operator. All right, let's move on. The next logical operator is OR. OR is another logical operator. Again, it is a Boolean operator. Instead of using the phrase A and, we just need to use OR. So again, to make it simple to begin with, we can consider two conditions and we can apply OR between them. 0 or 0, which is false or false. False or false is always false. False or true is true. True or false is true. True or true is again true. This is a truth table of OR. Let us look at some examples. 5 greater than 8, which is false. Or 9 less than 4, which is also false. False or false, meaning 0 or 0, which is false. So the result would be false. In the second example, 5 greater than 8 is false. And the second part of the condition, which is 9 greater than 4, is true, which means false or true, which results into true. When it comes to the third condition, capital letter C is less than capital letter F. Of course, yes, which is true. And remember, we are talking about logical OR operator. And if you observe the truth table carefully, at least one true condition is enough to turn the end result into true. Hence, when or is applied, once the evaluation results into true of any particular condition, it may skip the rest of the conditions which are part of that entire expression, and it can immediately return a true value as a final result. So in the third example, C less than F is true. So it need not check for 9 less than 1. The result would be already true. Cat is less than cap, which is true already. So it did not go and check for the second part, which is again true, 1. So the result would be true. Let us go back to ideally and practice this. 0 or 0 is 0. 0 or 1 is 1, which is 1 or 0, which is 0. Sorry, which is 1. It is OR condition. Sorry. 1 or 1, which is 1 again. So if you look at all these 4 examples, at least one true condition is enough to make the result. Here the result is true, here the result is true, here the result is true. The other way is to check with false. False or false is false. False or true is true. True or false is again true. True or true is again true. This is how the OR condition evaluates. Let us take some conditional examples. 5 greater than 8 or 1 greater than 3. The first condition, which is false. Sorry. The first condition, which is false. And the second condition is also false. False or false is false. 5 greater than 8 or 3 greater than 1. The first condition is false, but the second condition is true. So the end result would be true, because we are using OR logical operator, either this or that. Correct? Next. 5 less than 8 or 1 less than 3. If you look at the first part of the condition, 5 greater than 8 is true, and one true condition is enough to make the end result true. So it did not even evaluate this. It doesn't even check for this. It can immediately conclude that the result is true. Similarly, 5 less than 8 or 1 less than 3. Both the conditions is true. However, it doesn't even need to check the second part, because the first condition is true. The result will be true. This is how the OR condition, the OR logical operator can be used within the conditions. Now, you may use OR for multiple times. True or the end result would be true, obviously, because at least one true condition is enough to make the end result true. False or false or false or again the result will be true, because at least one true condition will turn the end result to true. Again, false or false or false or false. The result would be false, because there is not even at least one true condition So the result will be false. All right, let's move on. The third logical operator is not, which is again a unary operator, meaning it works on single condition. How? Not zero. First of all, zero stands for false. Not false. What is not false? Not false is true. Similarly, not one. One is true. Not true is false. Or you can directly apply not on false keyword or true keyword so that you can get the negated result. Okay. Let us take some examples on ideal. Not true. Not true is false. Not false is true. Not false is not zero. Not zero is true. Why? Zero is false. Not false is what I'm asking. So not false is true. Similarly, not one. One is true. Not true is false. So this results in false. Alright? So not is used to negate the meaning of the actual condition. I will say not 5 greater than 3. 5 greater than 3 is true. Not true is what I'm asking. Not true is false. So the result will be false. Not 5 less than 3. 5 less than 3 is false. Not of false. Not false is true. So the result will be true. And remember, not is used only on one operand. 5 less than 3 is the operand of not logical operator. That way, not is different from logical and logical or. Logical and logical are the binary operators, while logical not is unary operator, means it acts upon only one operand. While logical and logical or, they need two operands to work upon. You may have a question. In examples like this, we have used more than two operands. That's correct. However, the evaluation follows a specific order, and every time it evaluates two operands and it gets some Boolean result, either true or false. When I say Boolean result can be either true or false. Repetitively, it considers that end result of these two, and again it applies that result along with this false, applying the or operator between them. This is how, at any given point of time, it evaluates only two parts of the condition. All right. So, not 5 greater than 8. 5 greater than 8. First of all, the condition 5 greater than 8. Is it true or false? 5 greater than 8. 5 greater than 8. The condition 5 greater than 8 is false. So not of false is true. So the result will be true. 5 less than 8 is true. Not true is false. So the end result will be false. And capital C is not equal to capital C. It is like a character is not equal to itself. No, which is false. Not false is true. So the result will be true. Cat equal to cat. Yes, cat is equal to cat. Not of true is false. So the result would be false. So if you want to really play with this, the same way, you can also try this. You can use 0 and 1, 0 and 0, 0 and 1, 1 and 0, 1 and 1. And you can also apply OR between these. Always keep in mind that 0 means false, 1 stands for true. Okay, there will be only four possibilities when you consider two possibilities here: 0, 0, 0, 1, 1, 0, and 1, 1. All right. And when it comes to not of 0 is what you can evaluate. Second part is not of 1 is what you can evaluate. and here is the result. 0 and 1 is, it is AND, keep it in mind. 0 and 0 is false. 0 and 1 is also false. 1 and 0 is also false. 1 and 1 is true. 0 or 0 is false. 0 or 1 is true. 1 or 0 is true. 1 or 1 is true. Not 0 is true. Not 1 is false. You may have to by heart this truth table so that you can guess how a condition involved with logical operators is evaluated. All right, that is all about logical operators in Python. And let's move on to something called range. Range is a class in Python. And we're going to talk about this range with 7 different examples or points. So what is range? First of all, it's a built-in feature to generate a sequence of numbers. So if you want to really generate some numbers, you can use this range class. So range generates numbers lazily, meaning it creates the values only when they are needed. It doesn't simply create all the numbers upfront and store them in memory, but only when the numbers are required, then only the numbers are generated by this range function. And this range is a zero based, it follows a zero based indexing. That means it always starts with 0 by default. If you don't specify anything, it always starts with 0. Let us take some examples to understand this better. All right. So range is a class, as I said, and within the brackets you mentioned 5 in this case, and you have assigned that entire statement to another variable called r. Now we are going to print r. Okay. So what you get is range 0 comma 5. Where did this 0 come from? That is what the third point here indicates, that range follows a 0 based indexing. It always starts with 0 by default. If you don't mention anything, it always starts with 0. The next statement is to print the type of or. What is a type of or? It is nothing but a class range. This is what I already indicated, that range is a class in Python. So if you assign a range statement to a variable, and if you ask for the type of that variable, it explains it as a class type, class range type. Now if you want to really print what are the values within that range 0 to 5, this is what you need to use as a statement: print star r. As you see here, these are the numbers that are generated. This is a sequence of numbers generated automatically by range class. Okay. So the meaning of range 5 is nothing but please generate the numbers starting from 0. You didn't mention 0 anywhere. However, by default, it treats that it has to generate the numbers from 0. And remember, you have asked the numbers up to 5, but keep it in mind that whatever you mention as argument to range, that is exclusive, meaning it doesn't consider the number you have asked for, but it just follows one lesser than that. Hence, it has generated the numbers 0, 1, 2, 3, 4 only. 5 is exclusive. So, the start value is inclusive. If you have to mention the start value, I'll give some examples. However, you need not mention the start value. If you don't mention the start value, then 0 is a default value issue. In this example, you are printing range of 3 to 9. Here you are passing 2 arguments to range. In statement 1, you have mentioned only 5, single argument, but here you mentioned 3, 5, which are 2 arguments. So here 3 is treated as starting value, and a 9 is treated as ending value. As I said, ending value is exclusive and starting value is inclusive. So it generates the numbers starting from 3 and then 4, 5, 6, 7, and 8. See, 9 is nowhere in the result generated. Why? Because the end value is exclusive always. This is very, very important thing to understand in Python, that for the range function, the end value is always exclusive. So end value or stop value is what we call. End value is exclusive, but it is mandatory to mention. So in statement 1, whatever that 5 we mentioned, it is treated as a stop value or the end value. In line number 5, statement 5, 9 is treated as a stop value and 3 is treated as a start value. That is where we say start value is optional. In statement 1, you did not mention any start value. Still, it assumed the starting value as 0. In statement number 5, you explicitly mentioned the start value, which is 3. And you also explicitly mentioned the end value, which anyways end value is mandatory to mention. So 9. So it could generate the numbers 3, 4, 5, 6, and 6, 7, and 8. The third variation of it is you can pass 3 arguments. 3 here, the first 3 is a starting value. The 9 is end value or the stop value, which is exclusive. And 2 is the step value is what we call. With this, you can see the output. 3, after that, it did not produce 4, but it just simply adds 2 to that 3, which is 5. That means you are jumping by 2 digits. 3 plus 2, 5, 5 plus 2, 7, 7 plus 2 is 9. You reached the stop value, and the stop value is exclusive, so it stopped over there. It could print only 3, 5, and 7. That's all. So step value is again optional, because if you look at statement 1, you mentioned only end value. You did not mention the start value or step value. And the default step value is always assumed to be 1, right? That is where it is evident in both statements 1 and 5. The numbers generated are just incremented by 1, right? And the last example, range can also be used to generate numbers in descending order as well. In this example, 7 is a start value, 2 is a stop value or the end value, minus 2 is a incremental value or the step value. Okay. So you need to start with 7. Every time you need to add minus 2 to 7, right? And you get some result. That result again add minus 2 to that. That is what the meaning here is. So first 7 is what is generated. 7 plus minus 2 is 5. 5 is what generated. Okay, and 5 is still within the limit of 2, right? You should not fall beyond 2 is what it says. Then 5 plus minus 2 is 3. Okay, well, 3 is also within the limit. 3 plus minus 2 is 1, but the end value is only 2, so you can stop there. So 7, 5, and 3 are the numbers that are produced by range in this example. So it is all your creativity to generate the numbers using range, where you want to generate the numbers in ascending order or descending order. How much should be the difference between two consecutive numbers that you want to generate? All these things are under your control. Let us now practice this. First of all, if you want to know the help, you can of course do that. Okay, it has 83 lines of help generated, and if you can ask, please provide me the help. So this is all the help about this. I said range is a class. Yes, it is a class. And stop is mandatory. You have to mention the stop. At where you need to stop is what stop value you need to mention anyways. And then you can also mention start. You can also mention stop, where step is optional. Okay, and it returns an object that produces a sequence of integers from start, which is inclusive, to stop, which is exclusive by step. Range ij produces I, which is a starting point, I plus 1, I plus 2, up to j minus 1, because j is top value, which is exclusive, so it has to go up to j minus 1 only. Okay, this is a documentation. You can go through this and understand. The only thing you need to understand at this point of time is three things: start, step, and stop. All right. You don't mention any argument, then it will be an error. Why? You need to mention at least the stop value, right? So you just say 5. See, it has generated you that range object to 0 to 5. Then say star range of 5. Sorry, you cannot use start expression directly here. Probably what you can do is you can use print here otherwise. Star range of 5. As you see here, star range of 5 has produced these numbers. It is a number generator. Range is acting as a number generator. It starts with 0. I did not ask to start with 0, but by default it has assumed that the start value should be 0. And 5 is not inclusive. That's where we say 5 is exclusive. So if you want to generate the numbers, simply you can use this kind of statement. I want to generate the numbers well, up to 10. If you want to get it up to 10, you have to mention 11 over here because the end value is exclusive. So this is how it has generated, starting from 0 again up to 10. Okay. I don't want to start with 0, but I want to start from 1. Then you need to also mention the start value. Range, content star of range 1, which is a starting value, and mention the ending value. Close print. See, this is how you could generate the numbers 1 to 10. Does it make sense? All right. I want to generate only odd numbers. 1, then 3, then 5, 7, 9. So, a small tweak to the earlier statement. Start from 1, go up to 10, but I need to mention 11, and 2 is a step. Sorry, I need to close the brace. You see, 1, 3, 5, 7, 9. Makes sense. This is how you can generate odd numbers. You can also generate even numbers. If you want to generate even numbers, starting from 0, go up to maybe 11 and mention it as 2. Here you need to explicitly mention the start value. Okay. So as you see here, a 0 is a even number. Next 2, because your step is 2 here. It keeps adding 2 to the previous value. This is how you could generate the even numbers. This is how you can generate the odd numbers. Okay. Step is same, end is same in both these cases, only the starting point is different. Okay. How can I generate the multiples of 5? How can I generate the multiples of 5? Multiples. Multiples of 5. 5 is multiple to itself, right? I want to generate up to maybe first 10 hours. Okay, then mention it as 5 hours. And see, you see, these are the multiples of 5 now. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And if you want to generate more numbers, you can increase the stop value or the end value. I have got up to 51 only. If you want to go further, you can, of course, you need to understand which lever to control to generate different output. That's all. I want to go up to 100, again 5. You see, it has generated the multiples of 5 up to 100, right? All right. And let us now focus on the decremental part of this. So, decremental part meaning your starting values may be 50, end value is I want to go up to 20, meaning I need to mention it as 19, and I would like to make a step of, let us not make any step for now. Okay, I by default step is what? 1, positive 1. That is where it cannot produce any output. What did you say? And starting point is 50, ending point is 19. So 50 and default step value is 151. But here you mentioned that don't exceed 19, but 51 has already exceeded 19. That's why you did not get any output, right? That is where if you want to generate some numeric values in descending order, you explicitly overwrite the default incremental value of 1 with something else. As you see here, starting point is 50. You said every time decrement by -1 or decrement by 1, right? You won't be able to see 19 because 19 is a stop value which is at stake. So you always, sorry, this is where you see all the numbers generated in descending order, right? Now I want to generate multiples of 5, okay, in descending order, okay, starting from 50. You see 50, 45, 40, because every time it is decrementing by 5 from the previous value. And finally it has come down to 1 because 0 is exclusive again. So this is how you can generate the multiples of any given number just by using range class. All right. So range is commonly used with for loop. As you can see here, start value is optional. By default, it treats it as 0. Stop is must. Step is optional. By default, it assumes it to be 1. Now, we are going to talk about iterative control structures in Python. In the earlier session, we have covered decision control structures. Now we are going to talk about iterative control structures. Okay. So while is a keyword in Python followed by a condition and then colon, and some indentation must be used to specify the body of the while. Okay. Afterwards, the statements that are outside can be again left indented to the maximum possible extent. In this example, statement 1 to statement n, these fall under the body of while. And how this while condition works is the condition will be evaluated. If the condition is true, if the condition evaluates to true, the program control flow enters into the body of while. It executes all those statements within the body. After that, it once again gets back to the condition and evaluates the condition with the latest value of the variables. If the condition remains true, it once again executes the statements within the body. And again it goes back and checks the condition. This is what a repetitive control structure or iterative control structure behaves. Okay. In the place of while, if you just use if, and if the condition is evaluates to true, it executes the body only once, and it doesn't go back and check the condition once again. That is a key difference between decision control structure if and a iterative control structure while. Okay. And how many times this happens? It happens as long as the condition remains true. Once the condition evaluates to false, it completely skips the body of while and it continues to execute the statements x, y, and z in this example. So, whatever statements you keep within the body of while, those are the statements that get executed repeatedly. All right. So, this is how you should understand the syntax and execution flow of while. And there is a second iterative control structure that Python supports, which is a for. And as you've just seen using the range, right? Range is used mostly in for loops. So for is a keyword again in Python. In is a keyword again for some variable. I have taken here. You can put x, you can put p, you can put y, anything in range n. And then the statements that you want to execute repeatedly, as long as the condition remains true, have to be indented to the right. And the statements that you want to skip or you want to exclude them from the body of work, they have to be left in intervals. So in this example, as long as the value of ii is within the range of n, right, exclusive, the statements 1 to n will be executed and repeatedly, because once the body is executed, again the condition will be checked, and if the condition remains true, it goes and executes that once again and again, again and again, again and again. Once the condition becomes false, it comes back to statements 5, 6, and 7 and it executes once. That is how the for loop is what we call a iterative control structure. Repetitive control structure is what we call. All right. Let us look at their execution part. So let me drive programs, Python programs. Okay, let me take something and I will just type in some code here. For ii in range 10, for example. What is it you want? Sorry. What is it you want to do inside the body? I may print ii. I may also print ii times ii. Okay. Then I may print by. All right. Like this. As you see here, first of all, you need to understand range. Did you mention the start value? No. Start value has been assumed as 0. Did you mention the end value or start value? Yes. Which is 10 exclusive. That means it looks up to 9 only. Perfect. Did you mention the step value? No. Step value is assumed to be 1. Okay, let us start how this has been producing this produced this result. 0, II becomes 0. You are printing II, which is 0. Then you are also printing II times II, which is 0 times 0 is 0. That is why you got the first line. After that, being an iterative structure or repetitive structure, control goes back and it consumes the next value from this range, which is 1 because step was automatically assumed to be 1. 0 and then 1, right? II is 1. Print 1. 1 times 1 is 1. Print that. Go back. Consume the next value, which is 2 into II. Then 2. 2 times 2 is 4. That is how this line of output has been generated. Next, II becomes 3. 3 is printed. Double of 3. 3 times 3. 9 is printed. Next, II becomes 4. 4 and 16, 5 and 25, 636, 749, 8 and 64, and 9 and 81. Right? And that's all. We're done. This loop. Y has been executed only once. So this is a statement which belongs to the body of this for loop, which executes repeatedly. Sorry about that. So this is how range can be used with for loop. What if I have to achieve this using while loop? Same thing, I want to achieve this through while loop. Comment, edit. Comment out. Okay, perfect. Now, if I have to use while loop, I may have to start with 0 myself and then I have to write the condition. While I less than, you want to go up to 9 only. So I less than 10. Print and also square of it. And remember, I am not using any range here. So I need to myself increment the loop variable here, which is nothing but I. So that I starts with 0. 0 and 0 will be printed. Then 0 plus 1 is 1. I will become 1. Again, the condition will be checked. 1 less than 10 is true. Here it comes in. 1 will be printed. 1 times 1, 1 will be printed. I will be 2. Right? After evaluation, I becomes 2. It again goes and checks 2 less than 10. Yes, true. 2 will be printed. 2 times 2, 4 will be printed. This is how you have to yourself take care of adjusting the value of the loop variable within the body of that loop constructor while. Whereas if you use for and range, you need not take care of it because range will automatically keep generating the numbers based on the start value and step value. All right. And finally, you want to print by, which is outside the scope, which should be outside the scope of the while. As you see here, this also has produced the same one. This was produced by while loop and this was produced by for loop. It's the only difference. Theoretically, whatever you achieve using for loop, you should also be able to achieve using while loop. Okay, and the extra overhead here, if you are using while loop, is you need to initialize the starting value to the variable. Okay, and you should also use a step value and increment to the value of the loop variable. Both of these will be taken care automatically if you use range and for loop. That is a key difference between while loop and for loop in Python. Make sense? So these are iterative structures. These are iterative structures. There are only two iterative structures in Python. Those are nothing but while and for. Okay. All right, let us jump on to the next topic. Yes, now we understood how to use these, how to code or how to use these iterative structures in code, and now what kind of programs can I develop using these two iterative structures. Okay, what kind of programs can I write? All right, I'll come to this later, but first I want to cover this print the numbers from 1 to n. Quite simple now. Can you print the numbers from 1 to n? Yes, it's quite simple to print the numbers from 1 to n. What is n here? N has to be given as input by end user. Using input function, you are going to take the input, enter the value of n. Okay, and keep in mind, input function always returns the result or the user given input as string. But for us, it has to be as integer. So I'm going to typecast this as integer. Now I need to generate the numbers starting from 1. So I can use for II in range. By default, it starts with 0, but I want to start from 1. So I need to explicitly mention the n value. Oh, sorry, starting value is 1. And I need to go up to n. So I need to mention n plus 1. Why? Because the end value or the stop value is exclusive. So if I want to print up to 10, I need to mention 11 as a stop value. And the step value is always 1. You needed to mention that. This is enough. In fact, if you want to explicitly mention, you can put a comma and mention 1 as well. Then what? Print the value of I. Makes sense. That's all, right? Enter the value of n, which is 10, for example. So it is able to generate all these numbers 1 to 10, right? Is this a dynamic program or a static program? I asked it to print numbers up to 12. Yes, you see, it could produce the numbers up to 12. So this is a dynamic program because it could interact with the user, and based on the user input, it can respond accordingly in terms of producing the output. Makes sense? So this is a dynamic program where you read the input from the user every time and you produce the numbers up to n. Okay. So this is a dynamic program. All right. There is no harm in explicitly mentioning the increment value. It also produces the same result. Okay. Do the same thing. And again, the requirement may be different. The ask can be different. Probably, if you want, if you are supposed to print it in the same line instead of multiple lines, you can say what is that you need to use. And equals to, we may give a single space or so. So that you can see all the numbers generated on the same line instead of multiple lines every time. So these are all the output manipulators you can use, and you can control how you want to generate the output, whether it should be on multiple lines, where it should be on a single line, so on and so forth. This is all what you need to control within your print statement, output statement. And this is a one which will control the numbers generated, and it will generate accordingly, and I value takes one value at a time out of that range, and it will be printed over here. All right. This is how you can print the numbers from 1 to n, where n is a user given input, runtime input. The next one is to print the numbers from n to 1. Okay. How do you do this? N to 1. So again, you read the input, but you need to print from n to 1. So n is the starting point for you, n to 1. So if you cannot put 1 here, because if you put 1 it won't be printed, so you need to put 0 over here, and every time you need to decrement by 1, because you are printing n to 1, you are descending order, right? Then bigger number to lower number, so the step value has to be -1. Okay, so you need to start from n, whatever user gives, and you need to go up to 1. So it is 0 as a step value, sorry, the stop value is exclusive, you need to mention it as 0, and increment decrement part should be -1 because it is decreasing trend. So let me run this. Say input is 10. It produces numbers 10, 9, 8, 7, 5, 6, 5, 4, 3, 2, 1, which makes sense. Also, I'm running the same program again with a different input. Yes, it starts producing the numbers from user given input 15 down to 1. This is a decreasing trend. All right. This is what the second statement asks us to achieve. Print numbers from 1 to n to 1. Okay. First one is an example of incrementing trend, and the second one is an example of decrementing trend. Here, the question is to print the number of digits in n. To print the number of digits in n, you need to first read. Okay, you need to first read the value of n. Okay, understand the question properly. Third problem is to print the number of digits in n. N is a user given input. So to read the n value, you use a variable called n, and you first read the input and you store it in n as integer. You take digit count, okay, which is another variable to keep counting the number of digits in n. Assume that the user has provided 12 as input. So for your understanding, there are multiple two variables here. No, one is digit count, the second one is n. Assume that n has been given as 12. Input is 12. Digit count is 0. Now you check the condition. N 12. 12 greater than 0. Is 12 greater than 0? Yes, it is. That means the condition is true. So I need to go and execute the body. Now, digit count 0 plus 1. 0 plus 1 is 1. Store it back into digit count. So digit count is no more 0. Now it would be 1. Digit count value is 1 now. Okay. 0 will be overwritten with 1 value. Next statement. N is 12. 12 divided by 10. Integer division. Keep it in mind. 12 when divided by 10, the quotient, integer quotient would be 1. So here n is no more 12. N becomes 1. All the statements within the body are executed. And now I need to get back to condition once again because it is an iterative structure. N value is 1. 1 greater than 0. Yes, 1 greater than 0 is true. Again, get into the body. What is the digit count? It is 1. 1 plus 1 is 2. Store that 2 into digit. So now the old value 1 will be overwritten by value 2 in digit count. After that, n is 1. 1 divided by 10. The quotient would be 0. So n would become 0. After that, check the condition once again. 0 greater than 0 is false. Once the condition becomes false, come out, print this. Digit count it 2 by a time and print that 2 value. Okay. This is how you can count the number of digits in a given number. Okay. Quite simple. You need to make this number 0. See, 12 is becoming 1, 1 is becoming 0 eventually. Every time you get into the loop, You are pretty sure that there is at least one digit in the given input n. So increment your digit count. Since you already counted one digit, you remove one digit from the number. How can I remove one digit? Any number you take, if you divide the number by 10 and consider the quotient as a new number, that means you lost one digit already. Another couple of examples I can give you. For example, the number is 351. You divide this number by 10, integer division, you get 35, right? See, you lost one digit already. That is what you want because you already counted one digit. So whether you remove one digit, this digit or this digit doesn't matter, but you need to remove one digit. That's what happening. You do this repeatedly. Now 35 is there. You already counted one digit. You remove one digit, then it becomes 3. Next, the same that number becomes 0. So removing the digit in the units place is always easy and simple because by just doing an integer division on that number and considering the quotient to be the new number would be very easy and can be achieved within a single statement like this. Hence, you always divide the number by 10, 1 is lost. Divide the number by 10, 5 is lost. Divide the number by 10, this is the only digit in the units place. 3 is lost and the number becomes 0. That's the reason as long as n is greater than 0, you are doing this. Alright. Now, there will be one corner case over here. What if the given input is 0? N is 0. 0 has how many digits in it? 0 itself is a digit, no? So the number of digits will be reported as 1. But the way you have written this code, it prints it as or it reports it as 0. Why? Let us understand it. N is 0. Digit count is 0. 0 greater than 0 is a condition to be checked. Condition is false. 0 greater than 0 is false. So right away comes to this statement and prints digit count at that time. Digit count is 0. It prints 0, which is wrong. So my input is 0. My expectation is to be 1, but it doesn't happen because 0 has one digit in it. This happens only for 0 input. I give 7 as input, it prints 1. So how can we avoid this? What you can do is, if user given input is 0 itself, you can immediately make the digit count as 1. Okay, that's all what you can do. Run it now. Input is 0. Yes. 0 means it has one digit in it. 7 has one digit. Sorry. 10 has two digits. Five digit number I have given, I will be able to compute the number of digits in it. Clear? So to find the number of digits in a given number, this piece of code is enough. So you read the input used from the user, maintain one variable to count the digits. This is a corner case condition. If user produces 0 as input, assign 1 to digit count because 0 is also digit. Then as long as n is greater than 0, keep counting one digit and also remove one digit from n. This is what repeats. Finally, the number of digits will be shown here. And if the expectation is to print the number of digits in so and so is this much, you cannot use n because n has already become 0. So for that, you may probably use a temporary variable and store n value into that. And here you can say in T. Okay, use this way. Okay, as for example, I use 0. So the number of digits in 0 is 1. Correct? I give a 2-digit number. Number of digits is 72. Correct? Anything. Here we got 7 digits. 1, 2, 3, 4, 5, 6, 7 digits. This number. All good. This is how you can print the number of digits. You can find the number of digits in n, where n is a user given. The next one is to print the sum of digits in n. Again, quite simple. This is also based on the same principle of removing one digit from the given number every time. And here you are supposed to find the sum, right? Sum of the digits. So you can use some variable called sum. And what you can do is you can add up how it is. Remember that achieving the digit in the units place is more easy. To achieve the digit in units place, you can use modulo division operator by 10. Example, 15 is your input, 1, 5, 15. 15 mod 10. 15 when divided by 10, you get a remainder of 5. So I am always extracting the digit which is in the units place and then adding it to sum. After that, I'm also removing that 5 from the given number because I have already accounted for it. As simple as that. Sum of digits in T, because n will be again becoming 0 here, is stored in sum. 34. It is 7. 3 plus 4 is 7. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 7, 22. 22 plus 1, 23. How does it work? Quite simple. Only two things you have to keep in mind always in such problems. If you want to extract the digit which is in the units place, see, if I give you some number like this, it doesn't matter whether you keep adding the digits from left hand side or right hand side. I have chosen to pick the digits from right hand side because it is more easy for me and convenient for me for my programming. I consider this number as n. And see how this program works. Of course, there is also a variable called t into which n value, initial value will be saved. So 345 saved just for future use. That's now sum is 0, n is 345, the same n value is assigned to t as well. Check the condition. 345 greater than 0. Yes, 345 is greater than 0. Yes. Okay. Get inside. Sum 0 plus then what? 345 modulo division 10. When you divide 345 by 10, what would be the remainder? Remainder is 5, which is nothing but the digit in the units place. That 5 you add it to the sum. 0 plus 5 is 5 and store it in the sum. So update the sum to 5. How did you get that 5? That 5 is nothing but the sum that you have considered the digit 5 into your sum. Since you already considered 5 into your sum, you should extract this and ignore it, remove it. That is where the next statement does that. N is 3 over 345. 345 integer division 10. When you divide 345 by 10, what is a quotient? Integer quotient 34. So now the number becomes 34. Since it is an iterative structure, it again goes and checks the condition. 34 greater than 0. Yes, 34 is greater than 0. Again, get into the body and execute the statements. Sum, which is 5 plus n more 10. N is how much? 34. 34 when divided by 10 gives you a remainder as 4. Add that 4 to sum 5. 5 plus 4 is 9. So this is going to be 9. This 9 has been built by adding 4 plus 5. This is how you are keeping on adding the digits in the number and storing them in the sum. Well, after that, since you already considered 4 also, you have to extract and remove, get rid of 4 from this number. So the next statement helps for that. N is 34. 34 by 10 integer division. Then 34 by 10 is 3. So the number now becomes, all right, iterative structure. So go and check the condition once again. N is 3. 3 greater than 0 is true. Sum is 9. Get into the body, right? 9 plus 3 more 10 is 3. When you divide 3 by 10, what is the remainder? 3. Add that 3 to 9 so that you get 12. 12 will be stored in sum. N by 10. 3 by 10 is 0. Right? So this will become 0. Check the condition. 0 greater than 0 false. 5 plus 4, 9. 9 plus 3 is 12. So you already got the value of 12 into this. Okay. And since the condition is false, you come here and you print the values. Sum of digits in T is 345. Sum is 12. So this is how you get the sum of digits as 12 for a given input of 345. Run this for the input of 345. As you see here, the sum of digits in 345 is 12. So that is what this fourth statement refers to print the sum of digits in one. The next one is to reverse the given number. Another interesting one, again, based on the same principles. We read the input. So if the input is 345, the reverse of this is 543. That's what you need to do, right? So again, you take some variable called reverse, visualize to 0 as long as n is greater than 0. What you need to do is you just need to consider the reverse, multiply it by 10, and then add the units place digit. I'll explain this. Okay. Let us again take the example of 345. N is 345. Instead of sum, now I have a variable called RVD, which is initialized to 0. Good. N is 345. The same value is also stored in T. All right. Now think of this. If I have to reverse this, my expectation is to get 543. 543. If I write down 543 here, the digit which is in the units place in the given input has gone into most significant digits place, which is hundreds place in this case. So what I can do is I can consider this number and I need to somehow keep building this number by taking one digit at a time from the user given input. How can I do that? For that, you consider one digit, which is 5. How, where did I consider one digit? This is where I could consider one digit. If you get confused with this, you can also write that statement explicitly. So I'm going to have digit as a separate variable. At this point of time, n is 345, 345 modulo division 10. When you divide this number by 10, what is the remainder you get? 5. So digit will become 5. Right? I have extracted the digit unit which is in units place in the given input and stored it in digit. Then 12 reverse is 0. 0 times 10 is 0. 0 plus digit. 0 plus 5 is 5. So reverse is 5. 0 times 10, 0, digit is 5, 0 plus 5 is 5, stored in reverse itself. So reverse has become 5. Since you have already considered 5, extract and get rid of this 5 from the user given input. That's what this does, right? So 345 when divided by 10, what is the integer? Quotient, which is 34. So you got 34 over here. Well, being a iterative structure, go and check the condition again. N is 34. 34 greater than 0. Yes, 34 is greater than 0. True. Extract the digit from N again. N is 34. When you extract the digit in units place, when you divide 34 by 10, the remainder would be 4. Store that in digit. So now digit would be 4. Come to the next statement. Reverse is already 5. 5 times 10 is 50. 50 plus 4, 54. So reverse has become 54 now. Reverse has become 54. Look at this carefully, how we are constructing the reverse number from this in reverse order. 54, right? Next, since you already considered 4 in your reverse, get rid of it. So 34 integer division 10, get rid of 4. So we'll be getting 3 into n. N is now 3. Go back and check the condition. 3 greater than 0. 3 greater than 0 is true. 3 greater than 0 is true. Getting once again. 3 more 10. 3 modulo 10. When you divide 3 by 10, what is the remainder? It is 3, no? So digit would become 3 now. Reverse is 54 already. 54 times 10, 540. That is how you are pushing all the digits in the reverse to the left every time by multiplying that by 10. 540 plus 3, 543. So now reverse has become 543. N is 3. When you divide 3 by 10, what is the quotient? 0. Check the condition once again. 0 greater than 0 is false. 0 greater than 0 is false. Come out. Reverse of t. T is 345. Reverse of 345 is 543 is what you can see in the output. You see, reverse of 345 is 543. Yes, you can test this with different variety of program, variety of input. You see, reverse of this 8900986554, right? So this is how you can develop such programs. This is about reverse printing the reverse. Next, check if n is palindrome number. Quite simple, and this is just nothing but an extension to the previous program. You already know how to find the reverse of the number. Now, what you need to do is you need to check if the reverse number is exactly same as the given number. Okay, if the given number which is stored in t, because n becomes 0, don't depend on n actually. That's why safely we have stored n value into t before it has been changed. So you can compare the reverse value. For example, 343 is the input. What is reverse of 343? It is again 343 only. That means the reverse number and the given number are one and the same. Reverse is equal to 3. Then what you can say is t is palindrome. That's that. What if they are not same? For example, this is 123. When you reverse, or the same example, 345. 345 when reversed, you got 543. And this one and the user given input are not same, no? Then it would be a not palindrome number. So copy this line and just change the statement. Is not. All right, let us try this. For example, 121. 121 is a palindrome number because if you reverse it, you again get 120. Another example, 123. It's not a palindrome number. So 123 is not palindrome number. Okay, so this is how I want to make this big number as palindrome. So you see, you reverse this, you get the same number again. So this is a palindrome number. This is how you can check whether the given number is palindrome or not. Thanks to the end of session 5. In this session, what we have learned is to check or to develop programs using iterative structures. And we can also develop more interesting problems using these iterative structures, which will be covered in the next live session. Not only that, you will also learning how to get the printing patterns, stars, 1, 2, 3, diamonds, diamond shapes, triangular shapes, different shapes using characters, digits, symbols like stars, dollars, and all that stuff. So my main focus would in the next session would be on that. If you learn that, you can confidently say that you have good command on the iterative structures. All right. So stay tuned for that. And that's all for today. Take care. Bye.